I'm Anil Kumar sharing with you a test paper of my student, grade 12, data management. So this one is on organized counting and permutations. So let me first congratulate them for an excellent performance. I would like you to make a note of these questions as they may help you for your own test. So you can always pause the video, copy the questions. You can also look for their solutions since most of them are correct. So, that will help you to prepare for your own test. That's the whole idea. Now I'll take some of these questions to discuss in this video so that you can also perform as most of these students are doing. So let's take to the next page now. So questions on the next page are kind of like this. So there are two questions on this page, and then on the next page we have a few more thinking type of questions. Here is the one which you can look into. These are application questions, correct? Right, so these are a few more questions, right? So you can always pause and copy these questions. You can also look into their solutions if you want to. So here are two communication questions for you to understand. It's a lengthy paper. So now we'll take these questions one by one. Well, there's another section which is thinking section. So here are three questions on thinking which you make a note of. And then we'll see how to solve such questions. Okay, so I made a copy of 5 questions from this test paper. We'll discuss these 5 questions. The very first question here is question number 1, which says, how many ways can 3 red cars, 6 green cars, and 4 gray cars be lined up on the basis of color? Question number 2, in how many ways can you list the letters in Toronto if vowels must be grouped together? Question number 3, how many unique 2-letter words can be made from the letters in separated if only consonants are used? Question number 4, how many unique 2-letter words can be made from the letters in settlements? Question number 5, to start snooker, 15 balls numbered 1 to 15 are racked up in a triangular pattern with 1 ball in the first row, 2nd ball in the 2nd row, 3rd in the 3rd, 4th in the 4th, and below that we have 5 balls in the last row, beneath the 4th row, right? Now the question is, in how many ways can the 15 balls be racked with the black ball number 15 is never positioned in the middle of the 3rd row or as the lead ball in the row 1? So these are the 5 questions for you. You can now pause the video, answer these questions, and then look into my suggestions. Question number 1. How many ways can 3 red balls, so we have 3 red balls, 6 green cards, and 4 gray cards, and we have 4 gray cards. Okay, so let's say, okay, let me write gray here now, be lined up on the basis of color. So disregard anything else. So we have 3 types of colors here, red, green, and gray. So in how many ways can you arrange? So it's a simple question on permutation where we have a repetition, right? So in all, how many are there? So find the total. So total is 3 plus 6 plus 4, which is 13. So there are 13 factorial ways, right? Divided by 3 of each, they are kind of repeated, right? So divide by 3 factorial, divide by 6 factorial, and divide by 4 factorial to get your answer, correct? So that becomes the solution for the given question. So we can write this as 13 factorial, which is equal to a big number. We'll divide this by, within brackets, 3 factorial times 6 factorial times 4 factorial, bracket close, equal to, and the answer is 60060. Correct? So that is how you can solve it. So let's move on and take up the next question. Question number 2. In how many ways can you list the letters in Toronto if the vowels must be grouped together? So let's look into this word. Toronto, T-O-R-O-N-T-O. Now when we are saying vowels, A-E-I-O-U, so O's are the only vowels here, right? So we want to group O's together. Okay. So what we get here is one group where the O's should be together. So we have 3 O's here. We'll treat that as one group. Okay. Now let's look into the other letters. So how many T's are there? So we have 2 T's. Okay, 2 T's. O's we have already taken, these are 3 number. So O's are 3. Okay. And as far as R, others are all single, unique. R is one of them. And that's it. So we have 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6, 7 here. So we have missed what? N we missed. Okay. N. So we have single N, single R, 2 T's and 3 O's. So when you combine them and you want all the letters to be there, then what do we get? So we go 1, 2, 3, 4, 5, 6, 7 positions. 1, 2, 3, 4, 5, 6, 7 positions. If they have to be together, they may be anywhere, right? So these 3 are clubbed together. So effectively, you are left with how many positions? We are left with 1, 2, 3, 4, 5 positions. So that gives you 5 factorial ways. Correct? Now, we have to look for repetitions. We have 2 T's, so we have to divide by 2 factorial. Okay? So that is how we get all these combinations. Now here, this time we have 3 O's. Now these 3 O's can also be arranged in 3 factorial ways. However, they are triples, so we have to divide by 3 factorial. Correct? At times, there could be more vowels. So this is kind of important part of your solution. So that becomes your answer, right? So effectively, our answer here is equal to 5 factorial over 2 factorial. Is it okay? So we can now write down our answer as 5 times 4 times 3, which is 20 times 3 as 60. So 60 is the number of ways in which this arrangement can be, done, right? So 5 times 4 times 3, 60. So we can write down our answer as 60. Perfect. Now let's move on to question number 3. Here is question number 3. How many unique 2-letter words can be made from the letters in separated if only consonants are used? So let's look into this word. We have S-E-P-E-R-A-T-E-D. We are only looking for consonants. That means vowels will exclude. So we'll exclude A-E-I-O-U, right? So these will be excluded. So we are working with only S, P, R, T, D, right? So these are the consonants. Now, how many unique 2-letter words? So they are all no repetitions, right? So 1, 2, 3, 4, 5. So the answer is 5P. And we need 2-letter words, 5P2. That is the answer, right? Which is 5 times 4 times 3 times 2 times 1 divided by 2 times 1. So you get 5 times 4, 20 times 3 as your answer. Correct? So 20 times 5 times 4, 20, and 20 times 3. $60 as your answer. So that is the answer. Now let's move on to the next question, which is question number 4. How many unique 4-letter words can be made from letters in settlement? So we need 4-letter words. We are looking for 4-letter words. They may or may not have any meaning, right? So we have to select from settlements. SETTLEMENTS. So first, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. Okay. S. How many S's? So let's see how many S's. So S, we have 1 and 1. So we got 2 S's. Okay. So 2S. E. 1, 2, 3 E's. Okay. So we'll write E here, 3 E's. Let's talk T. 1 T, 2 T, 3 T's. So 3 T's. L. There's only one L. So 1 for L. E. We have already considered. M. 1M. N also 1. T we have considered. S we have considered. So let's recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So that is a good set to work with. Perfect. So now we need how many 4-letter words can be formed. So let's make 4 positions. 1, 2, 3, 4. Now we have to fill 4 positions. There could be different cases. So let's think about these cases. So let's say case 1. Case 1 could be all different words, right? So all unique letters. If we consider unique letters, we have 1, 2, 3, 4, 5, 6 of them, right? So out of 6, we have to consider only 4. And their positions matter, so it's permutation. So we get 6P4 as our first case. Is that okay? So these are total ways in which you can have words without any repetition. Now let's look into case 2. Case 2 could be that we have 1 double. Right? So 1 double could be either from the S's or from E. So there are 3 scenarios in this. So if you fixed 2 positions with a double, let's say you use E for example, then how many can fill the other 2 positions? So if I take away E, I'm left with 1, 2, 3, 4, 5. So 5 can fill up these positions. So we have from 5, we have to fill up 2 positions. And this operation can be done 1 double for S, E, and T. So for 3 different letters, correct? So we get these numbers. Now the third case could be that we have 2 doubles. Now 2 doubles means we could have 2 E's. And we could have, for example, 2S. Is it okay? So now we are working with 4 letters, 2 repeated. Correct? Correct combination with 2 E's, 2 T's. We could have 2 T's, 2S. So 3 times. So 3 times what? How many can you make with these 4 letters? That is what you're trying to see, right? So you're selecting 4 places, so which is 4 factorial, and 2 are double, so divide by 2 factorial times 2 factorial. Do you get it? So that is how you could do it. Now let's look into some other case where we could have a triple, right? I should write 1 triple. Okay, so triple is possible with E's and T's. So let's do another scenario. So we are now talking about triples, so we could do E's and T's. So if I take 3 E's, this position is left for 1, 2, 3, 4, 5. For 5. This position is left for 5, correct? Now the triple, so now we are actually selecting 1, 2, 3, 4 positions with 5 and 1 6 letters. Do you see that? So basically a triple really means that we have 2 kinds. So let me multiply by 2 first, since we could have triple with E's or with T's. Is it okay? Whenever you make a triple, you're actually using 1, 2, 3, 4, 5 and 1 T, 6 letters. So from 6, we are selecting 4 positions, and since we have a triple, this will be divided by 3 factorial. So those are all the cases, correct? So these are all the combinations which could form 4-letter words from settlement. So our answer is, so total is sum of all this. So our answer is, we have to add this up. So we have 6p4 plus 5p2 times 3 plus 3 times 4 factorial, which is 4 times 3. Let me write here 3 times 3, okay? So this is 9 times 4 times 3 times 2, which is 6, right? 6 times 3, 18 actually. Okay, so let me write this as 3 times 2, okay. Now plus 2 times 6p4. Well, let's not bother about it. 6p4 over 3 factorial. We'll use calculator. So 6p4 equals to 360. So this number is 360 for us. And then we have 5p2 times 3, which is 60. And this number is 4 factorial. So it is 3 times 4 factorial. And then we'll divide by 2 factorial. 2 factorial is 4, which is 18, right? So this is 18, okay. And the last number here is 6p4 will divide by 3 factorial, divide by 3 factorial, and then we'll multiply by 2. So we get 120 for this. Okay, so we'll add these. So what we get here is 360 plus 60 plus 18 plus 120. Let's add them up. So we have 120 here plus 18 plus 60 plus 360. And what we get here is 2580. So that is the answer for the given question, correct? So that is how we are going to do it. Now let's move on to the last question, which is question number 5. It says, to start snooker game, 15 balls numbered 1 to 15 are racked. So basically they are racked like this, right? So you got 1 ball, and then you got 2 here, and then you have 3 here, and then you got 4, right? So you get 1, 2, 3, and 4, and the last row has got 5 of them. So 1, 2, 3, 4, and then we have the 5th ball, correct? So they are placed like this. In how many ways can the 15 balls be racked with the black ball, which is number 15, is never positioned in the middle? So we do not want that ball in the middle. So we do not want this here of the 3rd row, or as a lead ball in row number 1. So we do not want one ball, which is number 15, in these 2 positions, correct? That is the question for you. So how do we do it? Means we have 15 different positions, right? So we have 15 different positions where black ball cannot take two positions, right? So let's begin that black ball is not in center, let us say, right? Now in such questions, what kind of strategy should you apply? As you notice, we see that number 15, the black ball is most restricted, right? It can take only 13 positions, right? It can take 13 positions only. We have two restrictions, right? So it can take 13 positions. So what is our strategy? So in such cases, the strategy should be first place the black ball, then others. Do you get the idea? So with this strategy, if you work, you can easily solve this question. So the idea is you can place the black ball in 13 positions, right? All these are 13. So we have 13 positions times all 14 in 14 positions. That means out of 14, they could be placed in 14. So the answer is 13 times 14 factorial. Do you get an idea? So that is how we should be answering this question. So let's do it. 13 times 14 factorial is a huge number. Okay, so let me write whatever it is. So it is 1.133 something into 10 to the power of 12. Is it okay? So that is what you're going to get as solution of this particular question. So I hope you understand and enjoy how we solved test paper questions. These were very interesting questions from the previous test paper on organized counting and permutations. Feel free to make suggestions. Also share your test papers. Those will be beneficial for other students. If you like and subscribe my videos, that'll be great. Thanks for watching and all the best.